Good evening, students. Mm, this is my this is the video that we already discussed the determination of transport number using the hit up method. In that hit up method, uh, we did the construction part, discussion part, and working principle. Today we have to discuss about the calculation, how you calculate the transport number. In the determine transport number, there are two cases arises. Case 1 is use of the inert electrode like platinum in which the ions are not attacked. The liberated ions are not attacked. That is called platinum electrode. Another electrode we have to use, that is called silver electrode, in which the ions are attacked. So two cases is there. First we do the case 1. Case 1 means we use platinum electrode. We use the platinum electrode. We use the platinum electrode. Platinum electrode. In this electrode, the ions are not attacked. The ions are not attacked. The ions are not attacked. That means whatever the ions liberated, silver nitrate ion, or we take the silver nitrate solution. In that of the silver nitrate solution, what we do now, silver ion, either silver nor nitrate will attack the electrode. That means you see here that is the anode compartment. This is my anode compartment. This electrode that we use, this electrode also we use. Now it is made of platinum. This is also made of, this electrode is made of platinum. This platinum electrode immersed in mercury, and this anode compartment contains silver nitrate. When when we put silver nitrate in water, it converted to Ag plus NO3 minus. Here the platinum electrode is inert electrode, so the silver ions are not attacked, or nitrate ions will not, because in case of anode, anion moves towards anode, so nitrate ion moves towards anode, but this nitrate ion not attacked the platinum electrode. Platinum electrode is remain intact because it is a neutral electrode. Okay, so in that case the platinum electrode, in this electrode the ions are not attacked. Then in this case how we do some calculation, that means in that case what we do now, in this case what happens now, this is the stopcock. After this is the stopcock, that means it is a like tap, you open it, these ions will move away. So first what we do, now we take the ions from the anode compartment. After electrolysis, we take 10 to 20 milliampere of current. After passing through 2 to 3 hours, then electrolysis is over. Then you open this stopcock and all the ions are collected from the anode compartment. You also collect from the cathode compartment, no problem. But any one of the compartment you have to take, no problem. In case of anode, we open the stopcock, remove all the silver nitrate solution, and in the silver nitrate solution by titration method you determine the concentration. So that means from this we start, and suppose you think that electrolysis is over, we open the stopcock and collect this silver nitrate solution, and the silver nitrate solution is titrated in order to find out the silver ions. Okay, in that, suppose that solution, when we decant from the anode compartment, suppose the solution weight is a gram. That means I write here a gram of the solution, contain silver nitrate. By titration method we have to see what is the concentration of silver nitrate. You can titration by any method, because sodium chloride, if you mention silver chloride, is not precipitated and settled down, so very easily it is precipitated. So a gram of the solution contain B gram. by titration method we see that b gram silver nitrate. A gram of the solution contains silver nitrate b gram. Solution means anodic solution. Anode solution. Anode solution contains b gram. Then the weight of water, can a gram solution means a gram solution contains silver nitrate plus water. That solution is a gram, and in the solution b gram silver nitrate present. Then weight of water is a minus b gram. Weight of water is 80 gram. That means a minus b gram water contain silver nitrate b gram silver nitrate, because the another solution what we decant, it contain water plus silver nitrate, and that solution weight is a gram. So by titration method we see that b gram silver nitrate is present. That means what is the weight of water? A minus b gram is the weight of water. So a minus b gram of water contains silver nitrate b gram. Then the equivalent weight of silver nitrate is atomic weight of silver plus nitrate, atomic weight of nitrogen plus atomic weight of oxygen. That means what atomic weight of silver is 108 gram. 1 nitrogen is equal to 14 gram plus 3 oxygen. 1 oxygen is NO3. 3 oxygen is 1 oxygen is 16 gram. 3 oxygen is 48 gram, which is equal to 16 0 2 2 4 plus 2 6 plus 1 7, 170 gram is then what is the equivalent weight? Atomic weight by valency of the cation. Silver valency is 1, so this one divided by 1 is equal to 170 gram is the equivalent weight of silver nitrate. Then a minus b gram of water contains silver nitrate b gram. Then what is the number of gram equivalent? Now a minus b gram of water contain silver nitrate is equal to b by 170 gram equivalent. We have to write b gram equivalent. Okay, then 1 gram equivalent of silver nitrate contain 1 gram equivalent of silver ion. Okay, 1 gram equivalent of silver ion, because AgNO3, one molecule contain 1 atom of silver ion, one atom of silver ion. AgNO3, 1 atom of silver ion, 1 ion of silver, Ag plus, and 1 of NO3 minus. So 1 gram equivalent contain 1 gram equivalent of silver ion. তাহলে এতিকি গ্রাম equivalent of silver nitrate is present. Then B by 170 gram equivalent of silver nitrate contain B by 170 gram equivalent of silver ion. Okay, can 1 gram equivalent of silver nitrate contain 1 gram equivalent of silver ion. তাহলে B by 170 gram equivalent of silver nitrate contain B by 170 gram equivalent of silver ion. That means A minus B gram water contain B by 170 gram equivalent of silver ion. Okay, that means A minus B gram water silver nitrate contain gram equivalent of silver nitrate. A minus B gram of water, তাহলে 1 gram equivalent contain 1 gram equivalent of silver nitrate, তাহলে এতিকি gram equivalent of silver nitrate contain এতিকি gram equivalent of silver ion, তাহলে this gram equivalent of silver nitrate present in A minus B gram of water, তাহলে A minus B gram of water contain B by 170 gram equivalent of silver nitrate. That means let B by 170 is equal to x. Say it is x. We take the x. Let it be x. When you put the value of b divided by 170, what is the value we get? Let it be x. This is before electrolysis. This is after electrolysis. This is after electrolysis. Then before electrolysis, what happened? Before electrolysis, what we have to do? Before electrolysis, what we do? Before electrolysis means when we do not apply current initially, because in the electrolysis we take 10 to 20 milliampere of current for 2 to 3 hours. When that current is not passed in the solution, that is called before electrolysis. Let C gram of anodic solution is let C gram of anodic solution contain D gram of silver nitrate. D gram of silver nitrate, whether it is visible or not. Visible, yes. C gram of anodic solution contain D gram of silver nitrate. Before electrolysis, that means before electrolysis, whatever the solution we take in the anode compartment, we have to weight it. That means C gram anodic solution contains silver nitrate plus water. Then weight of water is equal to C minus D gram. C minus D gram is weight of water. That means C minus D gram water contain D gram of silver nitrate, because this C gram anodic solution contain 80 gram water plus D gram of silver nitrate. Then C minus D gram of water contain D gram of silver nitrate. Then we have to find out gram equivalent. C minus D gram of water contain D by 170. Equivalent weight of silver nitrate is 170 gram. Equivalent weight. When you divide this is called gram equivalent. Gram equivalent of silver nitrate. Gram equivalent of silver nitrate. C minus D gram of water contain 80 gram equivalent of silver nitrate. Then 1 gram water. Then 1 gram water. 1 gram water contain silver nitrate. How much? Now here it contain D by 170. C minus D. 1 gram means divide by C minus D. D by 170. D by 170 multiply with C minus D. এতিকি গ্রাম ইকুইভ্যালেন্ট। এতিকি গ্রাম equivalent. 1 gram water contains silver nitrate, 80 gram equivalent. So that means 1 gram of water contain. But actually, suppose if electrolysis cannot be carried out, then we want to find out if electrolysis, suppose we think that electrolysis will not continue, then A minus B gram of water contain how much gram of, what is the amount of silver nitrate? 1 gram of water contain etiki. Then A minus B gram water should contain contain silver nitrate. That means A minus B gram water contain, what is the amount of silver nitrate? Should be contained like this: D by 170 into C minus D, then into A minus B. This is the gram equivalent. That means A minus B gram water should contain D into A minus B divided by C minus D into 170. एतिकी gram equivalent. Let it be Y. Let this value will come as Y. But we get less amount because due to electrolysis some silver ion will migrate. That means during electrolysis what happens, you see here this figure, you see from this figure that during electrolysis, so A minus B gram water, A minus B gram water should contain Y gram, because during electrolysis some silver ion will migrate from this to this, because cation move towards cathode and anion move towards the anode. So nitrate ion move towards anode and the cation silver ion moves through the U tube towards the cathode. So some silver ion will less. That means here we get what? Now the Y value, this Y value is greater than X. That means this much amount should remain. That means एतिक amount रहिबा कथा, किंतु रही केते ना मोर x gram. That means some silver ion migrate from the anode compartment to the cathode compartment. Then the migration of silver nitrate ion, the migration of silver nitrate, the migration of silver ion from the migration of silver ion, the migration of silver ion from anodic compartment to the cathodic compartment, is how much? Na Y minus एतिकी gram equivalent. That means this much amount of silver ion migrates from anode to cathode, and these ions will carry current. That means this Y minus X gram equivalent of silver ion carry current from anode to cathode. That means when we find out the transport number, we have to take only transport number of silver ion. How many gram equivalents of silver nitrate moves from anode to cathode? Let in the copper colorimeter, the amount of copper deposited, each Z gram. That means copper colorimeter means, in this case copper colorimeter means this here. In the copper colorimeter means this is the copper colorimeter. So in copper colorimeter, suppose I tell that copper is deposited in this copper colorimeter in the cathode is Z gram of copper deposited. That means this is called the black box of this instrument, because whatever the current passed through this copper colorimeter. From this case, what is the amount of copper deposited? We have to find out what is the amount of current passed through the. Suppose it is 3 ampere current pass here also 3 ampere current, because it is connected in series. So In that case, what we do? Let copper deposited is Z gram. Then the equivalent weight of copper is atomic weight of copper divided by valency. Valency is 2. Copper valency 2. Then atomic weight is 63.5 divided by 2 is equal to 31.75 gram. That is called equivalent weight. Then the amount of copper, the equivalent by the gram equivalent of copper deposited, the gram equivalent of copper deposited is equal to Z amount, Z gram divided by equivalent weight. That is called gram equivalent. This gram equivalent of copper deposited is like this. Let it be the Z by 31.75 gram is equal to the, let it be in the let it be anything else. Suppose you consider it P. This value you say P. In the note I think it is written double gram. Double gram divided by 31.75 is equal to Z. You take anything else, let P. P means this is the P where the total current passed through the solution. Then transport number of silver ion is the number of ion transport from anode to cathode. We have to see number of ion transport from anode to cathode, which is equal to Y minus X, because this will carry the current, divided by the total current passed through the instrument. Total current passed is P. This is called the transport number of silver ion, TAG plus. If you want to find out transport number of nitrate ion, then 1 minus eti, then transport number of nitrate ion is 1 minus Y minus X by P. That is called transport number of NO3 minus, because I know transport number of nitrate ion plus transport number of silver ion is equal to 1. If you get transport number of silver ion, then you can easily find out transport number of nitrate ion. So in this way you can find out the transport number of silver ion when you use the inert electrode. Now you use case 2. Suppose you have to find out case 2. When the electrodes are attacked, attacked means here you use silver electrode. That means silver electrode use. That means this electrode, whatever you use this electrode, this is made of silver. Instead of platinum, it is made of silver. And it is a mercury in contact. And this mercury in contact, because in order to make adequate electrical contact, that is why we put mercury. So in case 2, this electrode is made of silver. Then what happens? Now during electrolysis, the anion moves towards anode. This nitrate ion, whatever is there, nitrate ion will move towards the anode. When the nitrate ion moves towards the anode, it will attack the silver electrode and release some silver ion. That means in case of platinum electrode, platinum is the inert electrode. Though the anion moves towards anode, it will moves towards the platinum. As platinum is inert electrode, it will not release platinum. So it will not attack. That is why it is called not attacked electrode. But silver is attacked electrode. So when nitrate ion moves towards anode, it attacks the silver electrode and releases silver ions. Now the concentration of silver ion in the solution increases. The same process we have to take. You remove from the stopcock, you remove the solution and you measure it, let it be a gram, and suppose by titration method it contain b gram of silver nitrate. Same process, a gram of solution contain b gram of silver nitrate, just like previously we do. A gram of silver nitrate solution contain, that means the same process. A gram of solution of silver nitrate contain b gram silver nitrate. Weight of water is a minus b gram. Then a minus b gram of water contains silver nitrate b gram. Then equivalent weight of silver nitrate is 170. Then a minus b gram of water contains silver nitrate. Ethi gram equivalent. Divided weight divided by equivalent weight is equal to gram equivalent. Then 1 gram of silver nitrate is equal to 1 gram of silver ion. The 80 gram of silver nitrate is equal to B by 170 gram equivalent of silver ion. The A minus B gram of water contain 80 gram equivalent silver ion. B by 170 is equal to X. Now it is called as the X. Here in this case also same process. That means in this cases of we use the silver electrode. After electrolysis we can write that after electrolysis what happens? Now the number of gram equivalent of silver ion in the anodic solution is X. The same process, say X, let it be X, because nitrate ion moves towards anode, attack the silver electrode, then releases silver ion. So the concentration is more, the silver ion concentration is more, it should be X. So this is the content in the silver. So similarly, before electrolysis, same process we have to take. No, nothing problem. Before electrolysis, what happens? Now, what C gram of anodic solution contain D gram silver nitrate. Weight of water is C minus D gram. C minus D gram of water contain D gram silver nitrate. The C minus D gram water contain 3 gram equivalent D by 170 gram equivalent of silver nitrate. Then 1 gram of water contains silver nitrate is D by 170 3 gram equivalent. Then A minus B gram should contain 80 gram. It should contain 80. So A minus B gram should contain 80. Multiply this, let it be Y. So here in this case also, before electrolysis, the number of gram equivalent of silver ion in anodic compartment is Y. Say so Y. That means before electrolysis it contain Y. After electrolysis, silver ion concentration increases because anion moves towards silver electrode and releases silver ion. So silver concentration gradually increases during electrolysis. So after electrolysis 2 or 3 hours, X will be greater than Y. The number of gram equivalent of silver ion is X minus Y gram equivalent. Then that means in the experiment we do that. In the experiment we see that 80 gram equivalent. But theoretically, what should be the silver ion in the anodic compartment? From the copper colorimeter, from the copper colorimeter, the amount of copper deposited, amount of copper deposited is let Z gram. Then what is the gram equivalent? The number of gram equivalent, the number of gram equivalent is Z by 31.75. This is the gram equivalent of copper. That means let Z by 31.75 is equal to P. Say let it be P. That means this much amount of silver must be in the anodic compartment. But here we see only x minus y gram. X minus y gram is present. Experimentally we see that x minus y gram. But theoretically tells you P gram equivalent should be there. But it is less than. Then the remaining, where is it gone? It moves towards the cathode. Because silver cation moves towards cathode. So the silver ion moves towards the cathode side. So the amount of silver ion migrate to the cathode is, this theoretically tells that it should be ethic, P gram equivalent of silver ion. But experimentally we see that only this much amount is present. But theoretically tells that should be ethic amount. But experimentally only this amount is present. Then how many number of gram equivalent move towards the cathode? Now this one minus this one. Then the number of gram equivalent of silver ion migrate, the number of gram equivalent of silver ion migrate is P minus x minus y. This much amount x minus y. That means P minus x minus y gram equivalent migrate from anode to cathode, and this cation will carry the current. So this is that means when we want to find out the transport number of cation, the transport number of cation is T Ag plus is equal to number of gram equivalent move P minus x minus y divided by total current is P. This is the transport number of silver ion. Then the transport number of anion is TNO3 minus is equal to how much? Now 1 minus P minus x minus y divided by P. This is the transport number of anion, because it is known that transport number of cation plus transport number of anion should be equal to 1. Okay, this is how you find out the transport number using the experiment. So this is all about the calculation of the transport number. You will go through entire video, then you can find out easily. Okay, now we have to end here. So ଭଲ ଭାବରେ ପଢ଼ିବ, ଜମା ଭୁଲିବନି, କାହିଁକି ନା ଆଜି ପୁଣି ଆଉ 304 ସିଂହ ଆଉ ବାଘ ଯାଇଛନ୍ତି। ଏଇ ବାଟ ଆମେ ଦେଖିଲୁ ଟ୍ରକରେ। ତେଣୁ ସବୁ ଗାଁରେ ଆଉ 3-4 ଲେଖାଁ ଛାଡ଼ିଛନ୍ତି। ସେମାନେ 6-7 ଦିନ ହେଲା ଖାଇନାହାନ୍ତି। ତେଣୁ ତୁମେ ବୁଲିଲା ମାନେ ସେ ଧରିକି ପଳେଇବେ, ତୁମକୁ ଖାଇଦେବେ। ଆଉ ନ ପଢ଼ିଲା ମାନେ ଘରେ ପଶିକି ବି ତୁମକୁ ଖାଇଦେବେ। ତେଣୁ ସଦାବେଳେ ପଢ଼ିଲେ ସେ ସଦାବେଳେ ପଢ଼ିବ, ଜମା ବୁଲିବନି, ଟିଭି ଦେଖିବନି। ପଢ଼ିଲା ମାନେ କ'ଣ ହେବ, ସେ ତୁମକୁ ଛାଡ଼ିକି ପଳେଇବ। ପାଠ ପଢ଼ା ପିଲାଙ୍କୁ ସେ ଖାଇନି, ତେଣୁ ପାଠ ପଢ଼ିଲେ ସେ ଛାଡ଼ିକି ପଳେଇବ। ନହେଲେ ଜମା ବୁଲିବନି, ନହେଲେ ବାଘ ଧରିକି ପଳେଇବ, ଜୀବନ ଚାଲିଯିବ। ଓକେ ଓକେ।